Hello Algebra 2, let's talk about Chapter 2, Section 2, which is all about linear relations and functions. A lot of this I'm sure you have heard already. We are going to, in this video, identify linear relations and functions. What is the difference between those exact vocab words? And we're going to write linear equations in standard form. You might not have worked with standard form as much as you've worked with other forms, like slope-intercept form, y equals mx plus b, but standard form is good, it's helpful, so let's talk about that today. So, our first definition is a linear relation. So linear relations are relations, the combination of x's and y's, that have straight line graphs. So they are graphed in a straight line. The opposite then is nonlinear. We should be able to tell when a relation is linear or nonlinear just by looking at the graph. Our next definition, a little bit longer, a linear equation, and this is the one that we're going to work with a lot in algebra, solving these, graphing these, working with these, is an equation where the only operations are addition, subtraction, and multiplication or division of a variable by a constant. Variables cannot be multiplied or divided by each other. No exponents or radicals, and the graph is a line. It is a linear relation. So, some examples and non-examples of what that looks like, because seeing that on paper might not, just seeing that definition might not be enough for you to understand really what's going on there. And real quick, a linear function is the graph of the ordered pairs x and y that satisfy a linear equation. So if you can get x and y ordered pairs that satisfy this equation, you are good to go. So, like I said, examples and non-examples. An example of an ordered or a linear equation would be something like this. This is actually in standard form. So we have x, y, they're not being multiplied together, we're only adding or subtracting them, they're not being divided together, there we go. Another example, a little bit simpler looking, is something like that. Y equals 10. There's no x's, but that's okay, we're allowed to have just one variable, as long as the two variables aren't being multiplied together, divided together, there's no exponents, no radicals, all that good stuff. We are allowed to have division, but it has to be division by a constant. So maybe I have something like that, where I have division by 2. That's okay. Division by 2 is okay. Division by any constant is fine. Even if it's a decimal, that's fine. Last example, maybe we have something like this. I'm allowed to multiply by my x values, even if it's a fraction, even if it's negative, as long as, again, my x and y are not being multiplied together, no radicals, no division with those variables, all that good stuff. No exponents, no radicals. So, let's talk about some non-examples too. This is a non-example. That y is being squared, and that's not okay. We can't have exponents in linear equations. Another non-example, radical. We can't have radicals in linear equations. Squaring and taking a radical of things make the graph curve, and we need a straight line graph for it to be linear. Another non-example, if I ever am multiplying the variables together, again, that makes the graph curve, and that's not okay. Last non-example I have, of course there's more on either side of these. These are just a couple things to look out for. If I have 1 over x, so that's division by x, and that's not okay either. I can't multiply or divide x, or can't divide with the variables. I can't multiply the variables together. All that good stuff. Okay, so real quick, let's talk about these 3 examples, and I want to know whether these are functions, linear functions, or not. So first say yes or no, but then also explain why. Why are they linear functions, or why are they not linear functions? So take a look, and I want to know, the box will pop up on the side, do you think these are linear functions or not? If you said yes, tell me why. If you said no, tell me why. And the answers for the yes examples, it can be because it doesn't have any of these things. So take a minute, figure out, are these linear functions or not? So now let's talk about whether they are or not. This guy I see, excuse me, f of x, and remember f of x is just y equals all of this stuff. I could rewrite all of these like that, really. F of x and y are completely interchangeable. Okay? For this guy, I'm going to say yes, because I only see multiplication by a constant. And nothing more than that. I see some subtraction only, but as far as multiplying and dividing, only multiplication by a constant. Here, I am going to say no, because there is division by a variable, and that is not okay. And then the last one, I'm also going to say no, because I see multiplication with variables. And that is not okay either. So there you go, some examples and non-examples of linear equations. We've solved linear equations a lot, but now you officially know what makes it a linear equation. There we go. And if we were to graph this guy, the only one that actually is a linear function, we would have a line. Hooray. Okay, let's talk about a word problem that has to deal with has to deal with a linear equation. So here we go. The growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x, again that's the y value, is the total height in inches, x days after the initial measurement. So when we have x, y ordered pairs for this linear equation, x is days, y is the height in inches. So we keep that straight. So part A, how tall is the sample after 3 days? So take a minute, see what you can do with that one. How tall is the sample after 3 days? How do you use 3 in relation to this function? So now let's talk about that. 3 days, I already mentioned over here, x is my days. It says that right here. So I'm going to take 3 and find what is f of 3, the function value, the height at 3 days. And I am going to plug in 3 anywhere I see the x. I'm going to go to my calculator, figure out what 5.9 times 3 is. I get 17.7. 17.7. Okay, and then I'm going to add that 3.25. I get 20.95. And so that's my final answer. That is in inches. So 3 days after it is measured, I have a 20.95 inch tall sample of grass. There we go. Remember, there's no math that you need to do with the f of 3. This is just notation. Please do not now think you need to multiply by 3. This is your final answer right there. Cool. Okay. Well, next question. If the sample is now 50.45 inches tall, how many days has it been since the original measurement? So the original measurement, we're assuming, is when they figured out that this was the relationship that we're dealing with. So if now I have, this is how many inches it is, how does that fit into my equation? Well, I know that this is going to be the y value, and I need to know how many days, which is the x value. So I think I'm going to solve for x after I plug in y. So let's see what happens there. I am going to have f of x, which is my y value here, 50.45 equals 5.9x plus 3.25. Okay, so I'm going to solve for x. That'll give me the days it takes to reach the 50.45. I see multiplication by 5.9. I see addition by 3.25. According to my order of operations, multiplication happens first, addition happens second. Therefore, I'm going to undo this addition first, because I do my solving in the reverse order of operations. So I'm going to, I don't need my calculator for that one. It's going to be 47.20 equals 5.9x. This one I am going to need my calculator for. I'm going to divide by 5.9. Both sides. I get 47.2 divided by 5.9 8. How nice. 8 is my x value, so I can say it was 8 days. Took me 8 days to get to 50.45 inches. There we go. I'm going to break the video right now to start the next one because we're reaching a good time. So stay tuned for the next video.